Working? Yeah, okay. Hello everyone, good morning. I'm Barak Chamo. I come from London. I'm a software engineer doing front and back or full stack web and mobile development. And today I'll be talking to you about GraphQL, and we'll be talking about GraphQL from a RESTful perspective, from the perspective of REST web APIs. So first, I'd like just to introduce myself. So, as I said, I'm Barak. I've been doing JavaScript development for 6 or 7 years, starting off doing front-end web, and then doing back-end development with Node, now doing mobile development with React and React Native. And I'm really excited to see how JavaScript makes its way everywhere. And this is why I think it's very important for us to discuss technologies like GraphQL and where the web is going. So what is GraphQL? GraphQL is a query language, unlike something like REST where we use URLs to represent our data. GraphQL is a programming language essentially, or a scripting language for web APIs where we can describe the data that our application requires. So for example, if we were to use this RESTful API call to get a user in our system, to get a user with the ID of 1, to get the user record back, the equivalent in GraphQL, and we'll dig deeper into that, would be a syntax of a query. So what you see on the screen is the actual GraphQL syntax. It looks a lot like JSON, where we can request a user with the ID of 1, and we can say that from that user we want to get the ID, the first name, and the last name. So the query itself, and it's written down in text, not in URLs, encapsulates both the object that we require, the user with the ID of 1, and what we want to get from that user. So ID, first name, last name. And you can see that the response that we get back looks a lot like the query. The query looks almost like JSON. We get back a user object with the ID of 1, first name, and last name. But talking about users and records could get a bit dry, and we're in NodeFest, so I wanted to make things a bit more festive. Yusuke told me to get things a bit more exciting, so I thought, how can I make this a bit more festive? So, driven by my latest addiction, I'd like to introduce Pokemon QL, which is a project I've been working on, mapping the Pokemon universe to GraphQL, and I think it's the perfect example to explore the differences between REST and GraphQL. And we'll do that by comparing the existing RESTful Pokemon API versus PokeQL, and we'll see how they compare against each other. So, round 1 of this match is getting a Pokemon. We want to get a Pokemon out of our system, and let's see how we do that. First of all, REST. So as we said, a RESTful call. In this case, this is the actual Pokemon API. We'll hit a version 2 of the API, Pokemon, and 1. That's to get Pokemon with ID of 1. We're getting back a JSON object. We call it Bulbasaur. I know here it's Fushigidane. So yeah, names are translated to Japanese. And we get back the user record for, the record for that Pokemon, the full record. Now, that might seem simple enough. You know, we hit the API, we get the data back, but there are a few issues with the RESTful approach, and we'll hit them. Yes? That's what we have the, whatever's not with subtitles, we'll translate. Thanks. And if anything is not clear and you'd like further translation, maybe raise your hand or let us know, and we'll do that as well. So this was the REST call, the REST API, but there are a few issues. The first issue that we have is that when we look at this API, how do we know what we get back? You know, we hope that it's JSON, at least we pray for JSON, and not something that we can't deal with. But that's all we know. That is all we know about this endpoint that returns us the Pokemon number 1. So we go to the documentation and we read what the endpoint returns to us, because the API itself is unusable unless we have documentation describing what we have. And if we look at existing code in one of our projects and we see a call to an API, it's impossible to know what comes back. So yeah, we get the, we call the endpoint and we get the data back. And there's another issue, in that we get all of the data back. We get the entire Pokemon record. We get ID and name and height and weight and abilities, forms, species, all of these things. What if we just want the name? All we want is Fushigidane, that's it. To know the name of Pokemon with ID number 1. So we start doing something like this, where we say, I want the ID and the name and the type, and we start to pass parameters that say what is the data that we require. And that's not REST. That is a way we found to hack around REST to deal with REST not representing the properties of the resources. If REST is the representation of resources, we're not dealing with what makes the resources, what is a property, or what is a key, or what is a value. So we came up with this, with include, and that is what you'll find in most APIs. But things get very complicated when we want to talk about, for example, types, and we want to say, I just want the ID of the type, or the name of the type. And then we can say things like, include type ID and type name, and that include becomes very, very long and very, very complicated and very not RESTful. Let's look at the GraphQL approach. Sorry. Again, we describe it using a very elegant query language where we say we want Pokemon number 1, that is the resource, but I am able to describe what I want from that resource, so ID and name. And again, we get back ID and name. So we get a Pokemon, and this is how we call it in English, and we don't know what it looks like. And this is another very powerful feature of GraphQL, is the flexibility of queries. I can very easily just add a sprite here to get the image, and another property that I require in the query, and the sprite will be returned to me. And now I can see what Fushigidane looks like. So manipulating queries becomes very easy because they're very readable. It's the same structure as we're used to with JSON, and we can just read line by line what the properties that we get are, and what we put in, again, is what we get back. And the same goes for nested objects, nested data structures. So if a Pokemon has types, how do we say, I want the ID of each type, or I want the name of each type? What do I want to get from that object? You can see that because the structure looks a lot like JSON, we can nest our query parameters. So we can say for each type, I just want to get the name. I don't want anything else. And that is exactly what we get back. We get back the name of each type. And then we know that Bulbasaur is grass and poison Pokemon. So yeah, these queries can get very big and very nested, and they're still very readable, unlike a very long string of include parameters. The next thing I want to talk about, is the way GraphQL works. So we're in NodeFest, and we'll be implementing GraphQL in Node, and we need to understand what is the brain, what is the engine that parses these queries, because something has to be able to understand them, to parse what is a Pokemon, and what is the ID, and the name, and the weight, and height, and type. So GraphQL, the GraphQL language, or the GraphQL spec, is essentially a type system. A type system being a system that enables us to describe our data as different entities, and each entity has different parameters. So you can see in this example, it might be a bit small, so I'll just try to zoom it in a bit. You can see in this example, we define a type of a Pokemon. So that's something that doesn't exist in the RESTful model. If you're using an ORM, like SQLize or Bookshelf in Node, you know that you have to describe what your data looks like, what the properties are of each type. It's the same thing with GraphQL. So we describe our type of Pokemon as having an ID of the type ID. It would have a species of a type string. We define the static properties. So the species is a string, the name is a string, the sprite URL is also a string, and whether or not the Pokemon is a Mega Pokemon is a Boolean, because it's either true or false. So we describe the type of each property. We get a better understanding of the structure of the type. And we can also do the same for connections. For example, if Pokemon has different abilities, or different moves, or different types, or different evolutions, we can say that the type key or types key on the Pokemon is of the type, or of the evolution type, and we can describe the way that different types connect to each other. So, for example, the type evolution is, it has a trigger, meaning what is it that triggers the evolution? Is it an item? Is it a level? Is it level of happiness? And what is it? If a level is an integer and happiness is an integer. And we can also look at the Pokemon you evolved into, and you can see that the connection goes back into the Pokemon type. I don't know if I can highlight this, yes. So the evolution itself has a Pokemon as well, so these types can be interconnected to describe the entire graph of your data. So going from a Pokemon to an evolution, back to a Pokemon. And it's a very structured grid, or a graph, of your entire data model. Finally, we end up with the type of the query, which is the top level type in the graph, in the schema, your GraphQL schema, and that is how you enter. You saw that we made queries like Pokemon ID 1, and that is saying, I'm looking for a particular type, and I'm passing particular parameters. So this Pokemon accepts a search either by ID or a name, so you could search for Pokemon ID 1 or Pokemon name Fushigidane, and you would get it back. It's just like saying, in a RESTful model, Pokemon /1. Zoom back out. So this being NodeFest, what we care about is the Node implementation, because the GraphQL language needs to be converted somehow to JavaScript. And for that, we have a reference implementation. So GraphQL is developed by Facebook, and Facebook released an implementation called GraphQL.js that allows us to describe these models or these entities with Node. And what it looks like is much like the type definitions that we saw right now. So GraphQL types in Facebook, in JavaScript, are just extensions of classes. So we create a new class called Pokemon, and it will have all of the properties that we described before. It will have a name, it will be called Pokemon, it will have a description, and we'll see in a minute why the description matters a lot, and it will have all of the fields. So we can say a field ID is of type ID, field string is of type string, and field name is also a string. We can also define connections, just as we did before, between different class extensions, between evolution and Pokemon and types and abilities. And you can see something here that is the resolve function that we didn't have in the type system. And that is a bit of how GraphQL actually works, how a query actually works. When you query, and we'll look at the root query to understand this better, when you send a GraphQL query, it's a string. We say Pokemon, and we say ID, and name, and height, and weight. we sent this as a string. There are no URLs in GraphQL, unlike REST. So what parses that query? What parses that query is the JavaScript implementation that parses through our query and is able to say, you asked for a Pokemon, so I'm going to go to the database and get a Pokemon record back with the ID of 1. And I'll see what I can get from the object that I retrieved. I can get the ID and the name and maybe the sprite. These are all in the same response. But then we can ask for nested data related to that initial type. So we can say, we're looking for types. How do we get the types related to the Pokemon we already have? So we look back at the way resolutions are handled. And that is to say, when we get a Pokemon and we look for their evolution, GraphQL knows that it's a related type or a related resource. You can see that the type here is another one that we created. So we call this function, and it's automatically called only if we ask for the evolution field. And we call this function get Pokemon evolutions. We pass it the current Pokemon, and another database operation is being executed. So we make another query. And that is how we're able to make multiple database calls or multiple queries in just one GraphQL query. But if it's okay, it's good, we can move on. But the point is to say that when we look at a GraphQL query, we're able to ask for a lot of different parts of data in one. So in this example, and I want to go through the flow of a GraphQL query. Sorry, that should not be here. Here we go. First thing we do is we query for a Pokemon. We get it from the database. We have the ID, we have the name, we have the sprite, that's fine. Now we tackle type. Suddenly we don't have this data. We need to make another query. We will call the resolve function for the type field, and we will get those types back, and they will be merged into our response. And then from each of the types, we'll only get the name field. So we're able to create very, very complicated queries asking for a lot of data, and they will be resolved with individual database calls. And all of this happens in a single GraphQL query. So we make only just one query from our web application or mobile application or whatever calls the API, and all of these things happen in one operation on our server. So what do we gain? What do we gain with GraphQL so far? We eliminate request bloat because we're able to pick only the fields that we want. We can get ID and name and height and weight maybe only, and not everything else, not the big full response. We gain query flexibility because we can say, this is exactly what I want, and I can read it very simply. And we get self-documentation. Now, you've seen that in the types here, we gave every field a description. And for the type itself, we gave it a description. We're saying it's a Pokemon. Why did we do that? We talked before about documentation and how it's difficult to understand what an API makes available to you. Well, GraphQL, because of the structure of the type system, because everything is so well defined, provides us free of charge a tool that's called GraphQL. And GraphQL is a tool that consumes our schema, consumes our definitions of types, and provides us, and I'll zoom this again, provides us with an interface of testing our queries. So if you remember our schema starting from a query and a trainer that wasn't in the example, we can see that we have a Pokemon type. And if we go into that, we can see all of the properties that are available on the Pokemon. So we can look at ID and species and name and sprite and everything that's available, arrays of other types. If I see evolution, for example, I can click here and see what's available within the evolution. So the entire mapping is being processed, and we get this very elegant interface to explore our entire graph. And not only can we see it, we can query it as well. So I can run this query looking for a trainer, Pokemon, ID, all of that parameters, and run it and get the data back here. And I can try and add things, and I'll get auto-completion to know what fields are available to me. For example, evolution, and we'll extend it, and I don't know what's available. I can see that's a Pokemon available because we know that we are inside the evolution type right now. And once I go inside a Pokemon I can get the name, and that will give me the Pokemon that Bulbasaur evolves to Ivysaur. So we can explore the entire graph very simply with autocompletion. So even if you don't know what the API provides you, you can simply either read the documentation of the types or just experiment, see here what's available to me. For example, abilities. I don't know why the autocompletion isn't working. For example, within a Pokemon, what's going on? Oh, it's here. We have ID, and we have sprite, and we have species, so I can query for the species as well. And I can run this, and we get the species as well. Now, because this is Pokemon QL, I wanted to do something a bit more interesting, and I extended GraphQL into an interface that's a bit more fun to explore. So that is the Pokemon Pokédex that you can see here has this little nifty addition to the typical interface where you can play around and explore the schema and try and experiment with GraphQL, and you can run it, and you can get the data back, and it can be presented in this Pokédex interface. So for example, for a particular Pokemon, we see that the species is unknown, or the abilities are unknown. The abilities are here with question marks. So we can try and add them to the graph query and get the name of each ability and maybe the ID. And we can run that, and they're presented to us here. So it's a visual interface for if you're interested to try and explore GraphQL further. Moving on, we're getting to round 2, and that is more Pokemon information, and that is what happens when an API changes. Let's say we want to add a key to our API response if a Pokemon is a Mega Pokemon. How do we do that? Well, if we're building a RESTful API, if we're adding something or changing a key, we would typically want to change the version, so we don't harm previous clients of this API or previous versions. You can very easily end up with V1 and V2 and V3 and V4. Salesforce, for example, has over 30. One of the motivations for building GraphQL was Facebook, between all of their mobile applications, Messenger and Facebook and Pages, having more than 100 versions of their apps out in the wild. It's very easy to update a web application. You just have to press refresh in Chrome. It's very hard to update all of the people using an installed application. So you need a way of supporting all of these different versions at the same time without going insane, managing 100 different versions. Can you imagine? 100 different versions of your API. So back to the Pokemon schema, all we have to do is add Mega as a property of our type. And once we do that, we can ask for Mega back in our query, and we'll get it back. And the reason this is so different to the way we manage versions in REST is because that Mega will not be there unless you ask for it. You have to explicitly ask for new properties, and if you don't ask them, they will not be there, they will not bother you. And you can keep adding things to your API without confusing or bloating previous clients that already use your GraphQL endpoint. So yeah, no need to version, and I hope that this is visible. No need to, or less need, that will be more accurate, less need to version because we control exactly what a request returns. In round 3, and the last round, because we're running out of time, is to get more Pokemon things. How do we get more stuff from our API? So let's try to get 2 Pokemon, their abilities, and their types. If we were to do this with REST, we would make a call for API 1, another call for 1 abilities, another call for 1 types, another call for 2 abilities, types. To get these 2 simple pieces of data, we need to make 6 calls. Or we make this horrible call to API, multiple Pokemon with types and abilities, and you can pass IDs 1 and 2. Thankfully, this doesn't exist. I don't want to give the Pokemon API a bad name. But this does happen in other APIs. Instead, what we can do in GraphQL is create more advanced queries that get a lot more data in one single operation. So this introduces the concept of a fragment. So think of a fragment as a function in JavaScript, or as a sentence in a regular language that we can reuse, an expression. And we say Pokemon with evolution and abilities, or types and abilities, on Pokemon. And we save that fragment, getting back an ID and a name and abilities and evolution, saying exactly what we want from a Pokemon record. Then we can alias the Pokemon, saying, give me back a Pokemon, and call it Pokemon 1. And why do we want to call it Pokemon 1? So we can also get Pokemon 2 in the same query. And for each one, please use the fragment that I created, because I don't want to have to write this multiple times. And you can save this fragment, you can use it in multiple places on the query, and with this simple interface, we get back this big response saying Pokemon 1 and Pokemon 2, we know exactly what we want to get back from them, and instead of using something like multiple Pokemon with whatever, or making 6 different API requests, we can simply write down everything that we want for multiple types as well, and bunch all of this together into one single GraphQL operation. So we get everything we want in one request. I'd like to end by referring you to some JavaScript-specific libraries that you might be interested in. GraphQL.js is how you define the types, is how you define your GraphQL schema. GraphQL Express is what you use to actually expose an endpoint and make your GraphQL API usable. Because GraphQL only has one endpoint, it would usually be something like /graph. The query itself is sent as text or as JSON. And Relay, which I didn't have time to touch on today, but is a really, really cool library for building GraphQL-driven React applications. So if you use React and you use Node on the back end, or any language that supports GraphQL, it's a really cool way of making the two work together. You can go to graphql.org to learn more about GraphQL, and you can go to graph.pokaql.win to play around with the Pokemon API. And that's it. Domo arigatou gozaimashita.
僕がなんでここにいるかみんな疑問に思ってるところですけど、時間があんまりないので、できるだけ話してもらおうと思って、字幕をつけたり、ゆっくり話してもらったりして省略していました。GraphQL とRESTfulで、RESTful だとなんか必要ない情報とかもいっぱい返ってきちゃったりとか、必要な情報だけを取ってくるのがなかなか難しいんですけど、GraphQL で必要な情報だけを返してもらうようなことができる。何回もリクエストを投げたりせずに済みます。で、API のバージョンをアップデートするのも、バージョン1とかバージョン2とかセールスフォースみたいに何十個も作らなくて、ただ単にスキーマを増やせばいいだけです。すごくいいですよねっていうところをやっていました。ありがとうございます。Thank you. 質問ある方いらっしゃいますか？Thank you. Thank you.
今キーを増やすっていう話で、キーを増やすか増やさないかで、バックエンドの SQL に実際にクエリを投げるか投げないかみたいなところの制御ってどれくらいできるものなんでしょうか。
制約できないので代わりに答えますけど、リゾルバーっていうのを作れるんですね。で、それで細かい SQL を読んだり読まなかったりっていうのを途中で定義する。それで制御するため。
ありがとうございます。
これで、午前が以上になります。で、1時まで夕ご飯になります。We have last time till 1 o'clock. And for all guest speakers, we have lunch. Feel free to talk to staff. Thank you.